All right, so this question was brought to me to answer. Is actually not something that is covered on the AP exam this year, but it is something that's a part of BC Calculus. So I did want to make sure we went through it and could talk about where some of this comes from, just in case some of you are interested in the parts of BC Calculus that you're missing. Especially if those of you who plan on using this to kind of move you forward in your math to something beyond Cal 2. Um, anyway, this particular thing is dealing with parametric equations and vectors. You can see they give us that there's an object we're moving along that has this defined by these two different equations to determine its position. There's an equation for the x position and there's an equation for the y position, and both of them are using the same parameter t. So what I want you to kind of understand is that when we're dealing with parametric equations, what we're talking about here is an equation for multiple equations that are all connected to the same parameter. Okay, in this case, most of the time it's a t, and most of the times we're dealing with x's and y's. They give me a formula for the derivative of the x equation with respect to time. They do not give me one for the derivative of the y equation with respect to time, and they do in fact give me at a certain time what our position is, so some sort of initial position. So let's talk about the things that they want me to find. The first thing they'd like me to find is the x-coordinate of the position of the object at time 4. So this is something that you might have some intuition on how to solve, because we know that our new location um, is always going to be equal to our old location plus however much we changed, right? And we've talked before about how to do that, and that's by using some initial condition plus an integral from a to b of a rate. Okay, so in our case, what that means is our position at 4, the x position at 4, is going to be its old position, which is 1, plus the integral from time 2, which is the one where we knew it, to time 4, which is where we're trying to find it, of the rate of change of x as it relates to time, which they gave me in the problem is 3 plus the cosine of t squared dt. You do this, you put it into your calculator, and if I wrote it down correctly and can read my own handwriting, it is 7.133. This was worth 3 points on the AP exam, so you'd be already starting off at a great place. B was this question asking about a tangent line to the curve at the point x to y2. Now you can see that they gave me the initial position. Here it is, 1 and 8, so I have that part. What I really need to get now is the slope of this equation. So what I need to find is what is dy dx when time is equal to 2. Well, that is going to be equal to, in parametric equations, what it's equal to is the dy dt at time equals to 2 over the dx dt when time is equal to 2. And for some people, this is going to seem pretty intuitive. I take the y part, and divide by the x part to get dy dx. But this is the way we figure it out. And if I'm going to go about that, I wasn't given, excuse me, I was given dy dt at time 2, that is -7. I was given a formula for dx dt, and if I put that into, put 2 into that, that'll give me 3 plus the cosine of 4. And when I work that out, I'll end up with -2.983. When I take that and combine it to the initial condition that they gave me, the point, then I get y is equal to 8 minus 2.983 times x minus 1. Alright, so there we have it. There's A and B. C part is asking about speed. To figure out speed in parametrics, what we're really thinking you have to think about is the fact that we're going to be given maybe a velocity in the x direction and maybe a velocity in the y direction. And what we need to do is find out the magnitude of the resultant of those two vectors. So what we need to do is be able to find the hypotenuse of some sort of right triangle. So I have already know what both dx dt and dy dt are at 2. To find out speed, I need to take the square root of the x prime of 2 squared plus the y prime of 2 all squared. That'll give me my speed at time is equal to 2. So in this case, our speed is the 3 plus the cosine of 4 all squared plus -7 all squared. When we work this out, I got earlier 7.383. And lastly is the D part. And I'd say part D is definitely the trickiest of the parts of this particular problem. I'd say this was 6 points for A, B, and C. The last part I believe was 3 points if I'm remembering correctly. And this was all calculator active. I know some of you might have seen here at the top it was a problem number 3, but this is from 2004. And in 2004, the first 3 questions were all calculator active, and the last 3 questions were not. Okay, so let's see. They would like me to find the acceleration vector of the object at time 4. Well, to do that, what I need is I need x double prime at 4, comma y double prime at 4. That is the acceleration vector at 4. I can find out pretty simply what x double prime at 4 is. I take the derivative of x prime, which they gave me, that's dx dt, and that was, if you remember correctly, 3 plus the cosine of t squared. So if I take the derivative of this, x double prime, remember this is calculator active, so I didn't have to do all this by hand, but I'm going to show it to you just for this one. X double prime of t is going to be negative 2t sine of t squared. And so when I put 4 into there, I think that's where they wanted this, right? Yep, time 4. X prime double prime of 4. Then let's see, what I got when I worked the problem was 2.303. All right, now the tricky part is getting the second derivative of y because they didn't even give me a formula for y. But what I can do is I can kind of cheat my way there because they gave me what dy dt or dy dx is, excuse me, in terms of t. They gave that to me right here. So what I know is this means that dy dx, which is what they gave me, is equal to, I know it's dy dt over dx dt. If I solve that for dy dt, which is the thing I don't know, right? It's the thing I don't know. So dy dt over dx dt. I do not know dy dt, but I do know dx dt, and I have a formula for dy dx. So that means I can solve this and say, you know what y prime is? Y prime is dy dx, which is 2t plus 1, times dx dt, which is 3 plus the cosine of t squared. Now, I'm not going to work this whole derivative out by hand, but I can tell you that if you do the second derivative of this at 4, then you get 24.814, okay? So y'all can work that part out by hand. Take the derivative of that at 4. And then, to do this as a vector, which is what they wanted, you put it in triangle brackets, and you say 2.303, comma, 24.814. All right, I hope this problem made a lot of sense. I know it covered some ground we didn't actually do in class, so if it doesn't make sense, it's not a big deal for you guys in terms of the AP exam. Like I said, if you have more questions, feel free to ask. I'd be happy to help any way I can. See you guys later.